Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to Kirchhoff's laws applied to circuits involving dependent sources. So here we have this circuit here, and we have been asked to find the power delivered or supplied by this dependent voltage source, okay, this 3Vx. So again, this circuit involves the application of dependent sources, okay, how we can apply KVL and KCL in that. So let us redraw the circuit. Okay, 30 volt, 1 ohm, 3Vx, 0.5 ohm and 3 ohm. So here there are some important things. First, this is the current flowing. This is the voltage drop Vx on which this voltage dependent voltage source is dependent upon, Vx, which is the important parameter. Then we have to assign the voltage drops, plus minus here it is already there, plus minus, because current is flowing like this. Okay, another important thing is this voltage drop across this 0.5 ohm resistor Vx is equal to 0.5 I, because current I is flowing through it. So Vx is equal to 0.5 I, basic application of Ohm's law. This is very important. So now we have got all the things with us. So now we should apply KVL in this closed circuit. So when we apply KVL, the equation will be 30 minus I for this 1 into I plus 3Vx minus Vx, this voltage drop, minus 3I is equal to 0. Okay, then we have to bring the equation in terms of this I, single parameter. So we'll substitute Vx with 0.55. So it will be, that implies 30 minus I, this will be 3Vx minus Vx, it will be 2Vx. So 2 into 0.5 I minus 3I is equal to 0. That implies 30 minus I plus I minus 3I is equal to 0. I gets cancelled, minus I plus I. So we have the equation 30 minus 3I is equal to 0. That implies I is equal to 10 ampere. I is equal to 10 ampere. So we have got the circuit current. Now Vx is equal to 0.55. So Vx is equal to 0.5 into 10, which is equal to 5 volt. Vx is equal to 5 volt. 3Vx will be equal to 3 into 5, which is equal to 15 volt. Now you always know that whenever we have a dependent or an independent source, okay, current is said to be supplied from it, or that source is supplying current, that element is supplying current when current flows away from the positive into the negative terminal. Okay, this source V is supplying power because current is flowing away from the positive terminal and into the negative terminal. Here also the same thing is happening. If you see here, this 3Vx voltage source, current I is flowing into the negative terminal away from the positive terminal. So here this voltage source is supplying power, so that value is voltage into current, power supplied by this 3Vx dependent source is equal to 3Vx, the voltage 3Vx into I, this, that is equal to 15 volt into 10 ampere, that is equal to 150 watts. That is the power delivered or supplied by this voltage dependent voltage source. This is the answer that we want. Okay, this. So here again there are three important things here. First, basic KVL application, you have to be clear about that. Then how to treat dependent sources. So the important thing is to determine on which parameter of the circuit it is dependent. Here this voltage dependent voltage source is dependent on this voltage drop across 0.5 ohm. So that is the important thing. We established the relationship of this depending on the circuit current. Then we wrote the KVL equation. We brought the whole equation in terms of I. We got the value of I, the circuit current. Then we determined all the individual things that are required for this voltage dependent voltage source value to be determined, and then we got the value of this power. Here also this basic understanding of when an element is supplying power, when it is absorbing power, that is also important. So this is supplying power when current flows in this way, okay, like this. When current is flowing into the positive terminal and away from the negative terminal, in that case it is absorbing power. Okay, that is very important. I have said it many times. When current flows into positive, away from the negative, that is absorbing power. When it is flowing away from positive into negative, it is supplying power. Okay, this basic understanding is also important. So then you will get the result. Okay, simple question, but a lot of conceptual knowledge is there. Okay. Hello friends, so here we are with another question on KVL and KCL application in circuits involving dependent sources. So here we have this circuit and we have to find the value of this current I2 flowing away from the 16 volt voltage source in this part of the circuit. So let us see how we can deal with this circuit. So first let us redraw the circuit. This is 16 volt, this is I2, this is 10 V1 minus V1, 8 volt, this is 4 volt. Okay, so here what we have here is a voltage dependent current source, okay, this, and it is dependent on this parameter, this voltage drop across this resistor whose value is not given here. Okay, the value is not given here. This is the important parameter. So first what we have to do is we have to get the value of this voltage drop. No need to know the value of this resistance. Let us see how we can do this. Let us apply KVL in this left loop. Okay, So when we write the KVL equation, it will be second sign dominating method I am using, minus 4 plus 8, okay, minus for this 4 volt and 8 plus 8 for this 8 volt. Then minus V1 is equal to 0. That implies V1 is equal to 8 minus 4, which is equal to 4 volt. So see, we have got this voltage drop. So we have got V1. So this 10 V1 voltage dependent current, that will be 40 ampere. Okay, this voltage dependent current source, that 40 ampere. Now here if you see, I2 is equal to minus 10 V1 here, because they are flowing in the opposite direction. Okay, 10 V1 is flowing, it is assigned in this direction, 10 V1, I2 is flowing in the opposite direction. So of course I2 will be minus 10 V1. So that implies I2 is equal to minus 40 ampere, because minus 10 V1 is equal to 40 ampere, we got the voltage dependent current value. So I2 is equal to minus 40 ampere. This I2 is equal to minus 40 ampere. So we have got the result. So here simple application of KVL and KCL. We applied KVL here to get the value of this voltage drop. We use this value to determine this voltage dependent current. Simple application of KCL here. KCL or basic understanding of electrical circuits. These currents are directed in opposite direction, so of course it will be minus. Okay, so we have got the result, this answer. Okay.